to say their tech chats.
I'm not old enough to have walked uphill both ways to school or to have owned a rotary phone, but I am old enough to have rewound many videotapes before returning them to the rental store. Worse than all of those, I've used serial ports for a mouse and parallel ports for a printer. If you're young enough to have missed such a character-building experience, then you might not appreciate how revolutionary the original USB connector was for computer peripherals. USB Type-C is just as much of a step forward, and here to talk more about it are Bruce Rose from CUI, a Bell Group company, and Don Baldwin for Sager Electronics. Welcome to Tech Chats.
So, as Chris mentioned, Serial Bus, or Universal Serial Bus, or USB, has been around for a long time. It was created to standardize data communications and allow for connections of devices, like a mouse or a keyboard or webcam, something like that. But it also allowed for data transmission transfers. So, but one of the things they found was that you could also power devices minimally, but you could power devices off of the USB port. So the original USB connector was a Type A. It went in one way, which usually meant that it took 3 tries to actually get it plugged in, but it was low cost and it worked. As products developed, the connectors and the requirement for the connectors got smaller and smaller. So they went into the Mini A, the Micro B, which helped with smaller devices and plugging them in, but it also made it even harder to connect devices. Then they came out with the Type-C connector, which was revolutionary in many ways. One is it's reversible. You can flip it over, you can plug it in, no matter which way you plug it in, it works. They put pins on both sides that mirror each other. They had increased the number of pins in there, so not only did it increase the data rate that they could transfer, but it also increased the power that could go across that connector. So with the creation of this Type-C connector, the European Union sees this as a great opportunity to standardize. So as of 2024, they will require the USB-C type connector for a bunch of consumer electronic devices, cell phones, tablets, laptops. So we do see this as an opportunity and potentially growing the type of applications for Type-C connectors, and eventually maybe a worldwide requirement, not just a European Union one. The question now becomes, how do we use this to power devices? So, Bruce, with these USB Type-C connectors, what does Bell have to offer for USB-C type power supplies?
Yeah, so Bell and a subsidiary of Bell, CUI, does have both power supplies and connectors available for purchase right now. And as far as power supplies, we have wall mount or desktop supplies. And if you're going to use the USB-C connector and nothing more, then the recommendation is the supply ought to be limited to 5 volts, because just like with the Type A connector, that's what the user is expecting. And however, there's something more that USB has come up with. The Universal Serial Bus Group has come up with what they refer to as a Power Delivery Protocol, PD. And what this is it enables to output voltages other than just 5 volts. And actually the voltages can be 5 volts, 9 volts, 12 volts, 15 volts, or 20 volts. And then there's a further version of it that'll allow 28 volts, 36 volts, and 48 volts. And each of these can do up to 5 amps. So you can get up to, in the first version, 100 watts, and in the second version, 240 watts of power delivered through USB-C. In order to set the proper voltage level, however, there needs to be communication between the power supply and the load. And so that's something that's rather new. Now, the advantage of this is it eliminates this power supply clutter. I know I do, and I assume most other people do, have a drawer somewhere chocked full of power adapters that came from old products, and you always think that they'll use it on some new product, but it never works quite properly. So as I mentioned, that the thing that's different when you start implementing USB power delivery, USB PD, is that there needs to be communication between the source and the load. It's very important. It's how how the source and the load negotiate what the output power level, voltage level will be: 5, 9, 12, 15, or 20 volts, or in the second version, 28, 36, or 48 volts. And again, all these can do a load current up to 5 amps. But for the communication, there'll be a dedicated controller IC, both in the source and the load, to allow the communication to occur. Now, I've talked about that you need to have communication to implement USB PD. However, USB group was very clever and said, but we recognize not everybody is going to have communication available. And so there is the ability to run loads and supplies when neither of them or only one of them communicates. In that case, you will have only 5 volts transferred, but nobody gets hurt, if you will. And there, again, there are provisions for handling both of them, and there are signal lines that are described as to how to fake the communication, if you will, if one of the supplies doesn't, or the load does not have the communication built in through the controller.
So Bruce, let me see if I understand how the voltage is set using a PD device. So you plug the power supply in, you plug it into the end device, and the power supply puts out 5 volts. It says, okay, I'm just putting out 5 volts. I don't want anybody to get hurt, no damage to anything. And then the power supply says, hey, here's a list of what I can offer. I have 5 volts, I have 9 volts, I have 12 volts, up to 20 volts. What do you want? And then the load looks at that and says, hey, I need 15 volts. And the power supply says, okay, I'll give you 15 volts. Load says, hey, I'm happy with 15 volts. And it starts powering the device at 15 volts. And then if something happens somewhere along the line and they lose that communication, then it automatically goes back to 5 volts so that nothing gets hurt. Correct?
I agree. That's exactly how I view the communication occurs. And USB describes that's the way the communication occurs.
Okay. So back when we had the old USB Type A supplies, everything was 5 volts, up to 1 amp. There was no question or issue of putting too much voltage or too much power or anything into things. The only potential issue you had was either a bad cable or coming unplugged, or like I mentioned before, having a hard time getting it to actually plug in. Now with this USB Type-C and the PD device, we have this communication, we have these higher voltages, we have obviously this higher power, but there are power supplies out there that may not be a full 100 watts. So if you have a device that needs 20 volts at 5 amps, but you only have a device that, does 20 volts at 2.5 amps, you may end up having a problem and it may not be able to power the device fully. So just because this Type-C PD device and the protocol allows for 100 watts or 20 volts at, up to 5 amps, doesn't necessarily mean that the power supply you're going to get is going to be able to provide that much power. So there is still, as much as the device and the power supply can talk to each other to set the voltage, it's not going to be able to pull more power than the power supply can provide. So that may be the biggest issue that you run into with this. Now, talking about more power and what we've got going on, Bruce, you did mention the higher voltages and higher power. Is there additional requirements that go along with those higher voltages and higher power applications?
Yes, that's a great question. And the answer is yes, there are additional requirements, and that is that the USB consortium has defined what the cables need to be, and they've decided it probably makes sense or it does make sense to have intelligence in the cable. And so the cable is more than just copper and insulator. It has semiconductors for communication to negotiate with the power supply to make sure that when you're trying to supply a high power load, and primarily the ones over 100 watts up to 240 watts, that the cable is capable of handling that. And including, one of the concerns is if you're drawing 5 amps through the cable and you go to disconnect it, you may have some arcing and you may end up burning up the contacts in the cable because they're mechanically fairly small. And so one of the provisions in the high power cables is they detect when the cable is being disconnected and actually power down the load very quickly so as to minimize the arcing during disconnect. Now, let's talk about there's yet another feature that the USB consortium came up with, and that was beside the power delivery, and they call it programmable power source, or PPS. And if you remember when we just talked about the power delivery, it came in discrete voltage levels and fairly gross voltage levels of 5, 9, 12, 15, 20, 28, 36, 48 volts. There is the provision through PPS to be able to set voltage levels at 20 millivolt steps and output current limits at 50 milliamp steps. And this is a rather interesting feature that some users will find very useful. One example is battery charging. When you're charging, and we'll talk about lithium-ion batteries in particular, when you charge them, what you typically want to do is at the beginning of the charge cycle, you run it at a constant current. And as the voltage ramps up, it reaches a threshold, then you convert over to constant voltage. And so this PPS allows communication of the load to control the supply to do things like that. So that's one place where PPS is very useful, is you truly can use the power supply as a battery charger if the battery has the capability of communicating to the supply and controlling it. The other application would be to use the PPS as a variable output voltage power supply. And this brings up all sorts of interesting ideas and concepts. But what it's saying is if the load does not want a steady voltage, but for some reason wants different voltage levels, then there's the ability of the load to talk to the supply and have the voltage output from the supply tweaked as per what the load requires. Okay, so let's now look at some applications for USB Type-C, the connector itself. And again, keep in mind, we've talked about a couple different things. The Type-C, although we'll have to see what the general public, how they adopt these terms. From a technical perspective, Type-C is the connector itself. And so just like on the Type A, the connector we've always been using for USB, it's only 5 volts, and so therefore it's always safe to plug it in. We cause no harm. On Type-C, if all you're doing is implementing a Type-C connector, then the prudent thing to do is limit the voltage to only 5 volts and up to 5 amps. And again, this prevents when a user plugs it in, no harm, no foul, no damage caused, because everything is 5 volt compliant. And so where would you use a Type-C plug without anything more? Well, any place you would have used a Type A plug. It's more compact, it's reversible, as both Don and Chris pointed out. And so you'd use it any place where you might have been using a barrel plug right now. So now we've talked about just the USB-C physical plug, but if you, in addition, you choose to use USB power delivery and say, okay, I want the voltages available to 5, 9, 12, 15, 20, 28, 36, 48 volts, then with the communication through PD and the connector, the USB-C connector, this can be established between the source and the load. And again, with the first version, it's up to only 100 watts. When you get above 20 volts, the 28, 36, 48 volts, you can deliver up to 240 volts. Where could this be used? Again, any place a USB plug is used today, it can be used because it can deliver 5 volts and it can deliver 5 amps, which is up to 5 amps, which is more than the USB Type A plug could deliver. And a real quick diversion here. The USB spec limits you to 3 amps when you're at 5 volts, but the plug itself is characterized for 5 amps. And so it's non-compliant with USB, but no harm is done if you wish to use the USB-C plug to deliver up to 5 amps at 5 volts. And then again, most anything you can think of that's 100 watts or less probably uses a DC voltage somewhere between 5 volts and 48 volts. And some of it will use 3.3, so then you need a DC-DC converter in addition. But Any sort of load like that, you can think of the loads as being physically, I don't know, maybe the size up to a shoebox or a microwave oven or something like that. Most sorts of designs of that size will use power somewhere less than 240 watts and possibly even less than 100 watts. And therefore, the USB-C and USB PD are very applicable. Okay, so now we've talked about USB-C connector. We've talked about USB PD if you only want certain discrete voltage levels. If you need a finer granularity, the PPS, the programmable power supply, is available. And again, this produces a voltage from 3.3 to 21 volts. And a minute ago, I mentioned that if you need 3.3, maybe you need a DC-DC converter, or you could use PPS and get the 3.3 volts you need up to 5 amps. The first place where people tend to think of using this is a battery charger. So you don't need yet another circuit to convert the fixed output voltage from a USB PD to the required battery voltage and current. The PPS with the proper control signals from the load will take care of that. Or if you have a load with a non-standard output voltage required, that voltage can be either dynamically adjusted or set and left. And so, again, applications, battery chargers come to mind. As far as setting the output voltage, one example would be if you have a external power supply with a long DC output power cord, and you end up with IR drop down the power cord. The current times the resistance of the power cord causes a voltage drop. You could have an intelligent load that monitors what voltage is coming to it, and it can signal back to the power supply so that the voltage at the power supply is stepped up to compensate for the voltage in the cable drop. That's a very common application we see these days. And then also one can envision that there may be some loads that, depending upon the status of what's happening with the load, they want a different power supply voltage. And so it would communicate to the PPS to deliver different power supply voltages depending on what's going on at the load.
All right. Thank you, Bruce. That is great information on the USB Type-C connector, on the PD device, and PPS. We hope that this was informative for everybody. We thank you for taking the time, and we look forward to supporting you from Bell and from Sager Power Systems.
Thank you both. Once again, that's Bruce Rose from Bell Group's CUI and Don Baldwin for Sager. If you'd like to learn more about Bell's USB Type-C connectors and power supplies, click the links in the description or visit Sager.com. And subscribe to our channel to make sure you catch the next episode of Sager Tech Chats.